Alright, so in this video we're going to talk about the Pride of Trinidad. So the Chiconia, also known as the Pride of Trinidad, is a beautiful red flower that grows very rapidly. It is the national flower of Trinidad because it blooms on August 31st, which coincides with the day that Trinidad became independent from Great Britain. Consider the diagram below showing the growth of the flower using tiles. So here we go. This was, arguably one of the more difficult tile patterns that we've looked at this year, so we're going to break this one down of how we could generalize an equation for this. But let's start off with the first question, which is how is this thing growing? So if you just kind of looked at this, I think the easiest way to do this is to break it up into three parts, which is the stem, the petals, so these four petals growing out each time, right? And then of course the center, so this center square here that we see each time. Okay, so if you notice that pattern, what you could do is you could go ahead and draw day 0 and day 4. I think day 4 is a little bit easier to draw. So here's our day 4. Okay, so we notice that the center still has that square shape. Okay, I drew that because I saw, like, okay, day 1 it's 1, day 2 it's 2, 2, day 3 it's 3, 3, day 4 it's got to be 4, 4. Okay, done. Similar pattern with the petals. So you can see day 1, just one petal growing out. Day 2, two petals growing out. Day 3, three petals growing out. And then, of course, with the stem, if you kind of notice each time, it's just increasing by 1. So that one's not too difficult to do. And then if we backtrack, so day 4, like I said, is probably kind of easier to draw if you notice those patterns. But now going backwards, we could see that these four petals, well, that's the last time they could grow like that, so they're going to disappear. The square is also going to disappear, and then the stem's going to decrease by 1, leaving you with 3 squares for the stem there. So we're starting with 3. So the first question, if you were to count each one and sort of notice like how things are changing here, you would notice this. So we could see that it increases by 6, then 8, then by 10, then by 12. And of course, if you're analyzing this further, you could see that it has a constant second difference, increasing by 2 each time. So now that's convenient for us to know because we know that if it has a second difference, then we're going to call this thing a quadratic function. Okay? Now that's going to be further helpful for us because if we know it's quadratic, then we know that when we go to write the equation, there's going to be x squared in there somewhere. It'll be there somewhere. We just got to figure out where that's going to be. So let's jump forward and analyze this even further. So again, I said it's a good idea to go ahead and break this thing down into 3 parts. Let's start with the stem. Okay, so here's our stem. I highlighted it in red each time, alright? Let's break it down and look at it in a table. So day 0, you got 3 tiles in that stem. Day 1, you got 4. Day 2, you got 5, 6, 7. Nothing too crazy going on here. I think we could see that it's got the constant rate of change of increasing by 1 each time. Clearly it's linear. Let's go ahead and let's write a generalization for that, say with x. So let's just play a little guess my rule here. Question is what am I going to do to the days to get the amount of tiles? So what would I do to 0 to get 3? Well, that's pretty easy. I would add 3. Let's see if that works for day 1. Well, 1 plus 3 is 4. Nice. 2 plus 3 is 5. 3 plus 3 is 6, 4 plus 3 is 7, so the generalization would be take whatever the day is, okay, x days, and just add 3 to that, and boom. That is your generalization for your stem. And we talked a little bit about in class the connections here, so you guys could see that it's got that plus 3 and it also starts with 3, okay? And then it's also got that rate of change of plus 1, and then there's like this invisible 1 here in front of the x, just something to notice. Alright, so let's jump forward to our petals. So here we go. Highlight in pink, we can see that day 0, there are 0 petals, okay? Day 1, there's 4 of them. Day 2, there's 8 of them. Day 3, there's 12 of them. Day 4, there's 16 of them. We're looking for day x, generalization. So once again, I think this one is not too bad if you play a little guess my rule. Just the question, like, alright, what am I going to do to 1 to get 4? So if we go back to day 0, it's not going to be any addition here because, it looks like there's not going to be any addition here because, you're starting with 0. So it looks like it's probably just going to be multiplication or division. So what would I multiply 1 by to get 4? Well, that's pretty easy. 1 times 4. Let's see if it works going down the line. What's 2 times 4? Oh, that's 8. Oh, it worked. 3 times 4, 12. 4 times 4, 16. So we could see that it is going to be x times 4. Whatever x is, multiply it by 4, that's how you get those petals. And we could see that that kind of makes sense because each time it's just growing out 4 more. So a multiple by 4 would make sense, pictorially here. Now finally, let's take a look at the center. So filling some of these things in, the center is 0 for day 0. For day 1, the center is 1. For day 2, the center is 4. For day 3, the center is 9. For day 4, the center is 16. We're looking for day x. So now at this point, what I'd like you guys to do is be able to kind of look at how this thing is growing. So it's a +1, a +3, +5, +7. With some analysis, you'd probably realize that this thing has a second difference, which should tell you that, hey, this is the quadratic part of this flower. Definitely not linear. So that means if it's quadratic, it's got to have an x squared somewhere. Well, conveniently, this one is probably the easiest one to generalize because it is what's called the parent function. So looking at this, what is 1 squared? Oh, 1 squared is 1. What is 2 squared? 2 squared is 4. What is 3 squared? 3 squared is 9. What is 4 squared? 4 squared is 16. So you could see that whatever the day is, you're just squaring that thing, and that's giving you the amount of tiles. So if the day is x, square x, and boom, you got it. So now in order for us to now write this equation, given all these things, we just have to kind of combine all this, and then we will get our equation. I know this seems kind of daunting at first, but if you break it down into these smaller pieces, it's not really that bad. So let's combine these. Okay, we'll call this t of x, right? So for Trinidad, t of x. So here we go. We got x plus 3, that's from the stem, plus 4x from the petals, plus x squared. That's it. That's the equation. If you want to clean this thing up a little bit, here's how we could do that. So t of x is equal to, I'm going to put the leading term, which is x squared, okay, highest power. And then we could combine this x with this 4x, combining like terms, you'd have plus 5x, and I don't see anything else, any other constants here, so that would just be plus 3, and then there you go. You have an equation. So now using this equation, this will help us answer this question. Where is it? I don't think I have the question here, but the question is saying, hey, just like in the other one, there's some amount of tiles. Is this the correct amount of tiles for a figure number? So in this situation, it was for question 4. I'm assuming you probably have it in front of you right now. What I would do is one of 2 methods. The first method I would do is I would do some version of guess and check. I would, just like play around, be like, hey, I wonder if it's I wonder maybe if year 20 has that amount of tiles. So like year 20. And then go ahead and use your equation. So now you're going to have a 20 squared plus 5 times 20 plus 3, and see what you get. And, kind of just play around and see if you could get a year that has, the given amount of tiles. Another probably easier way to do this that'll get you somewhere a little bit quicker is just use technology. So I would go into my calculator, go into menu, table, let's put in our equation. It was x squared plus 5x plus 3. All right. And then, go down and see if you get, that specific amount of tiles for whatever the year is. This is a really easy way to, get that result. And then, of course, one justification is you could just, once you find it, you could copy your table down, and then you could write, because there's no year that actually has that amount of tiles, there's no possible way that, a year could have, that amount of tiles. That's one way to kind of disprove it, okay? So that kind of concludes it, right? So the big thing here was generalizing a quadratic equation. I think identifying it as quadratic is probably half the fight here. And that's really it. So if you have any further questions, feel free to just leave a comment here or send me an email, and that's really it. All right, have a good one.